Hello everyone. Today we are going to solve question number 171 on Official Guide Quant Review 2020 edition. This question is also known as PS7426 and you can find it in other editions of Quant Review as well. As always, if you find this video helpful, please do not forget to subscribe to my channel and like this video. It helps me a lot with YouTube. So let's get started. This question looks simple. However, people get stuck in understanding a few parts of this question. So we will unpack it step by step. Let's read the question once. N is given to be a positive integer. So that's a good thing. We know that n is a positive integer. And it is also given that n square is divisible by 72. So n square is a multiple of 72. Then the question says, then the largest positive integer that must divide n is, and it gives us different answer choices. And this is where things get a little bit difficult. So this part of the question, the real ask of the question, is what I would unpack first for you, because once you understand that, then how to solve this question and what is the strategy to solve this question would automatically become very, very clear for you. So let's get started. Let me take an example, a series for example. Let's take n equals 16k. It has nothing to do with what is given, just as an example. So what I am saying is n is again a positive integer which is a multiple of 16, and there are different values of n possible. So let's write that down for different values of k. So let's take k equals 1, 2, 3, 4. I will get n as 16, 32, 48 and 64. Now let's look at the question and see what it is asking us. So largest positive integer that must divide n. So in this series, the largest integer is 64. Now, is 64 a number that must always divide n? Let's see. If I divide 48 by 64, it's not possible, right? 48 doesn't divide into 64. Same thing with the other numbers. So you would see that 64 is not the possible. So that's not the largest number they are talking about. How about 48? Same thing, 48 doesn't even divide 64 evenly, let alone 32 and 16. And what you would realize is that the 16 is the only number in this series that would always or must divide n. No matter what the value of n is in this series, 16 is the number that will always divide n. But 16 is the lowest number in this series. Why are we calling it the largest positive integer that must divide n? So we know one thing. We know that 16 is a number that must divide all n, right? We don't know if it is the largest number. Why are we calling it the largest number? So let's look at what other numbers could divide n. 8. 8 is a factor of 16. If 16 is dividing all of these numbers, then 8 will divide all of these numbers as well. Similarly 4, similarly 2 and 1. So all of these numbers must divide n, and what you would see is in the numbers that must divide n, 16 is actually the largest, and that is why we are saying 16 is the largest positive number that must divide n when n is represented at this as this value 16k, right? So a couple of observations that will help us strategize and solve this question. First of all, the largest number on the series is not what we are looking for. We are looking for the smallest number in the series, and that smallest number, whatever that number is, will be the number that is the largest positive integer, because there could be other integers less than it which must divide n. So you have to figure out if you can express this n as a series such as I expressed here at 16 multiplied by k, and then find the lowest number in that series and that would be your answer. So that is the strategy. Express n in terms of something k to find lowest number of that series, and that will be your answer. All right, so now let's start looking at the first portion of the question and see if we can answer the question very quickly. So we are given n square is divisible by 72. So I'm going to write it as 72 times k. That k could be 1 or 2 or 3 or 4. N is given to be a positive integer. So n square has to be a perfect square. Let me write it in terms of squares. So 6 square multiplied by 2 multiplied by k. This is how I have factorized 72. 36 multiplied by 2, which is 6 square multiplied by 2. So if I were to find n, I can easily find n as root of n square. So that becomes 6 multiplied by under root of 2k. Now I'm in a little bit of a trouble because I definitely wanted to express n in terms of a number, a variable k, but not under root it. So how do I simplify it further? Here is some of the quantitative reasoning at this point that you would have to apply. Again, n is a positive integer, so this number must be a perfect square. What is missing, right? So this is a stranded 2. We need at least another 2 for this to work. So inside the root, the k must have, let me say this is k, must have another 2 to account for this 2, and these two 2's will combine and become 2 square, and also it can be a square of a different number. So something, let's call it m square. When I express k in terms of 2 multiplied by m square, this quantity inside the square root sign becomes 2 square multiplied by m squared, which is a perfect square at this point, which is what we expect, and n becomes 6 multiplied by 2 multiplied by m, because everything comes out of the square root sign, which becomes 12m. So now I am able to express n in terms of 12 times a number, right? 12 times a number. As we said that the series would be 12, 24, 36, and so on. And we said that the smallest number in this series would be the largest positive integer that must divide n, which is 12 here. So the answer to this question is B, number 12. This is how systematically you can approach the question. I hope you found it helpful. If not, put the question in the comment and I will personally answer each and every question. Again, if you liked the video and found it helpful, please do not forget to press the like button and also subscribe to my channel. Thank you very much.